I'm now setting up the test facilities to try to create a replica of cathodic protection using electronic components that I could put values to, and I'm going to use a breadboard, which is this. I'm going to use this, which is a multimeter with very good current measuring. This, which is a recording voltmeter through the RS-232C connection to this computer, which I've put into portrait so that we will be able to have readings from this meter here and the readings from this Dr. Duck oscilloscope, digital oscilloscope, which is connected through to here. They will all be on the top level, and this is the scope probes, which can be connected in the same way as we can connect the measuring probes from the 3 multimeters. This multimeter is also a data logger. So internally it will log up to 40,000 readings, and we can then download those through a RS-232C connection through here, and we can download this onto this same computer. So that's what I'm doing now. I've just cut out all these to see, cut out so as to mount these, and built the actual arrangement so that it's fairly secure and it's mobile, and I could start with the experiments. This here is my existing ORAC, which is an imitation of a cathodic protection system. This is looking at the surface, and this copper sheet is remote earth, and these are adjusters that we can make adjustments to the resistances in various parts of the circuit. The pipelines are underneath. Now, this is the ground bed, which is a whole series of randomly soldered resistors to mimic what we have in a ground bed when we put the charges into the ground at remote earth. When we put them in at a point, so we'll clip on to one of these points here, and they will go through all these resistances until they get to remote earth. The charge is then spread evenly over resistanceless remote earth, the mass earth. Okay? These are the pipelines, and because of the resistances that I've put in these pipeline conductors, it can represent, using the variable resistances, this pipeline can represent any length of any diameter of pipeline, and so can this. And this is a capacitor which is in circuit to mimic the capacitance of the whole system. So this is about the 4th or 5th of the ORAC series that I've made, and that will be incorporated into the remaining circuitry, which I will design as we go and explain as we go, and we will take real data on here. Now this is not all it's going to do, because I'm going to use other pieces of demonstration which actually have real steel pipelines in buried circumstances, and we can link these to this to show actual corrosion and measure actual corrosion at the same time as we're measuring the simulated corrosion on this test bench. Okay?